I'm Andrei, and I work for JetBrains as a Senior Vice President of Investments, Research and Education. Welcome to Regionals. Great things happen when great minds come together. JetBrains wants to seek out great minds all across the globe, support their initiatives, and work together to create great things that will make the world a better place. That's why JetBrains is proud to be a Global Tools sponsor of the ICPC. There are already many great minds working at JetBrains, and together we have created some amazing things, like the Kotlin programming language, for example. It keeps on growing and growing in popularity. In 2017, Google began officially supporting Kotlin as a language for writing Android applications. We have also created professional development tools like Cline for C++ programmers, IntelliJ IDEA for Java, PyCharm for Python, and also educational tools that help people learn and teach programming. The regionals are the biggest contest in the ICPC calendar. Thousands of talented people all over the world team up to solve complex real-world challenges. These contests are the proving ground for future champions. But even if you don't make it through to the finals, the experience of competing in the regionals and the new friends you'll make along the way are priceless. Enjoy the ride. Best of luck to everyone.
The next problem is lot of the group. Now we are going into the easy, mediums, and medium territory. And Kshitij will be explaining this. Author of this problem is Kevin.
In this problem, we have to find the number of subsequences such that for every pair of elements in that sequence, ai plus aj, there is an element with distance at most d. In this problem, d is at most 3. So the first observation is that there cannot be two numbers more than d. There some will be too large. We can prove this by contradiction. Suppose there are two numbers greater than d. We can take the biggest two numbers x and y greater than d. So x plus y will be greater than y plus x plus d and both y plus d. So it won't be possible to find any element with distance at most d. Similarly, without loss of centrality, we can also say that there cannot be two numbers less than negative d. The second observation is that if there is a set of valid elements and we add a number whose absolute value is at most d, we can add it and then also the sequence will be valid. Because xi plus c is always close to xi itself. Next slide. So now the array consists of at most one value greater than d, at most one value less than minus d, and some numbers which are not contained in the previous two base. So there are 4 cases which are listed here. We take no numbers which are outside minus d to d range. The case 2 is we take one number which is greater than d and no number less than minus d. And third case is we take no number greater than d and one number less than minus d. And fourth case is we take both one number greater than d and one number less than minus d. The first 3 cases are easier to count with the case 4. So we can count the numbers which belong to each of the 3 ranges. For case 1, there are 2 raised to the power m subsequences, g actually. For case 2, there are 2 raised to the power m into g. Case 3 is similar to case 2, so it's 2 raised to the power m into l. The only case in which we have to do more work is case 4. So we can say that there are 2 numbers x and y, which are not in minus 2 to 3 range. The observation is that x plus y must be near to some number with distance at most. Now, given that x and y absolute value is greater than 3, greater than d, So that number which they are nearer to has to be between -3 and D. So with some math, we can show that x plus y must be between -2D and 2D. So now once we have picked the negative number, we can iterate over all the possible 2D plus 1 numbers and check each of them individually. Now the sum is, we can take their sum x plus y. Now to choose from the remaining numbers whose absolute value is small, there must be at least one number. So say the numbers are -4 and 7 and D is 3, then their sum is 3, so there must be some number between 0 to 3 as well. So now we can, with some basic counting, we can count that. So once we have fixed the number, there are many solutions. So one in this solution, one is the inclusion exclusion, in which we can count the number of cases in which no number is in that given range. And the second solution is we can iterate over all the mass. So since D is very small, the complexity will still be small. So our best solution till now, the inclusion counting one is order D square plus ND. This can be improved faster with some more details which have been left as an exercise to the reader.